Look at our modern infrastructure. Steel and concrete bridges built just 50 years ago are already cracking, requiring constant, expensive maintenance. Meanwhile, stone structures built by the Roman Empire over 2 millennia ago are still standing, largely unbothered by time and weather. We live in an era of advanced technology, yet we accept planned obsolescence as the default. Why is it that with all our modern engineering capabilities, we still find ourselves studying the architectural and legal frameworks of a civilization that peaked 2,000 years ago? This chart highlights the stark difference in structural longevity. Look at the average maintenance lifespan of modern Portland cement on the left. You get 50 to 100 years. On the right, Roman opus cementitium breezes past the 2,000-year mark, actually getting stronger over time. Roman engineers functioned as ruthless systems optimizers. They prioritized extreme long-term life cycle ROI over short-term deployment speed, choosing to accept massive upfront friction to achieve near-zero long-term maintenance. By analyzing the inputs and specific trade-offs of 10 Roman innovations, we can extract actionable mental models. Whether you are writing software, scaling a business, or planning a city, these are the principles for building systems that actually last. We can map this approach using what we'll call the infrastructure matrix. The first node is material foundations, the physical bedrock layer that supports everything else. Roman concrete utilized hot mixing, combining quicklime with volcanic ash, carrying extreme thermal risks. But this yielded a massive advantage. Those white chunks are lime clasts. When cracks form, rainwater reacts with them, automatically healing the structure, creating a permanently self-maintaining material. Next, consider the Roman arch. Building one required precise stone masonry to cut wedge-shaped blocks, plus temporary wooden scaffolding to hold everything up securely until the heavy central keystone was finally dropped into place. The outcome was the ability to divert vertical weight outward and downward. This simple geometric rule allowed them to construct massive, multi-story open spans, like the Dome of the Pantheon, using a fraction of the raw material required to support flat beams. Then there was the highway system. Laying 55,000 miles of multi-layered cambered roads required immense state funding and staggering amounts of manual labor to dig deep trenches and fit the paving stones perfectly by hand. That staggering upfront cost delivered a massive logistical advantage. It practically eliminated geographical friction, allowing armies, trade goods, and critical information to move across the empire at speeds unmatched until the Industrial Revolution. In every case within their material foundations, the Romans accepted massive initial construction friction to permanently eradicate long-term maintenance and travel friction. That robust physical layer enabled the second node of our matrix, civic lifeblood. To make aqueducts work, engineers maintained precise, gravity-fed downward slopes over dozens of miles, building massive multi-tiered bridges to cross river valleys. These systems required a dedicated full-time maintenance corps and were highly vulnerable to sabotage. In exchange, they liberated cities from the constraints of local wells, delivering hundreds of gallons of fresh water per citizen every day. That massive influx of water became the direct input for subterranean sanitation. Runoff from the aqueducts and public baths was routed underground through structures like the Cloaca Maxima to continuously flush urban waste out of the city. This centralized waste management system drained uninhabitable swamps and established a scalable public health standard that allowed urban populations to safely grow to 1 million people. They applied the exact same centralized logic to temperature control. Hypocast systems pumped furnace exhaust through hollow columns under the floors of baths and villas. It required massive fuel consumption and intense labor to keep the fires burning, but it delivered total indoor environmental control. This systems thinking even extended to the battlefield. The Romans developed dedicated medical corps equipped with highly specialized bronze surgical tools, clamps, forceps, and scalpels, designed specifically to treat severe trauma. Pulling valuable resources and personnel off the front line to build this medical logistics network drastically reduced bleed-out rates. It ensured they maintained a highly resilient veteran fighting force. The Roman approach integrated public health and military endurance into physical design, managing biological resources with the same architectural precision as their stones. But physical hardware is useless without an administrative software code to run on it. That brings us to the final node of the matrix, The empire's operating system started with codified civil law. By etching standardized laws into stone and displaying them publicly, they stripped arbitrary power from ruling elites. This established core principles like innocent until proven guilty, creating a predictable legal environment for trade. Next, they standardized time. They abandoned the highly manipulable lunar calendar in favor of a rigid 365-and-a-quarter-day solar calendar, complete with leap years. Even with a slight 11-minute inaccuracy each year, this new Julian calendar immediately synchronized tax collection, timed agricultural harvests, and major military campaigns. Finally, they standardized information. The Acta Diurna were daily gazettes containing Senate acts, legal announcements, and military news, distributed rapidly across that massive road network. While it created the world's first mechanism for state-sponsored propaganda, it successfully forged a unified civic identity. Thanks to rapid couriers, citizens living thousands of miles apart from one another were continuously operating on the exact same civic dataset. The administrative code sacrificed the absolute flexibility of local rulers. In return, Rome achieved a rigid, predictable, and infinitely scalable operating system for the entire empire. The overarching Roman philosophy is remarkably consistent. Deliberately accept immense upfront friction in cost, labor, and administrative burden to guarantee near-zero downstream friction. For modern engineers and builders, the takeaway is to shift focus away from cheap, rapid installation and demand lifecycle durability. Treat self-healing frameworks and fail-safes as an absolute mandate, not just a luxury. For civic and corporate leaders, the lesson is structural. Your physical infrastructure, whether it's a software stack, an office layout, or a supply chain, is entirely useless unless it is explicitly designed to support the social infrastructure, clear communication, and legal frameworks riding on top of it. And for everyday optimizers, the lesson is in integration. Random, disconnected productivity hacks will always fail. You must build an ecosystem where the output of one process, like the runoff from a public aqueduct, automatically fuels the input of the next, like flushing the city sewers. Long-term impact comes from the ruthless integration and scaling of systems designed to outlast the builder.